All right, welcome back. So this is an ALEKS topic, understanding periodic trends in atomic size. This is a fairly straightforward little topic, but I think that it applies some different concepts, and we need to sort of understand both of those different concepts and then apply them together, which is sort of confusing, I guess. So basically what we need to do is just arrange these different atoms or ions, so these each set from largest to smallest. So largest is going to be the first one, and then smallest is going to be the last one. So largest to smallest, that's what we're going to be doing. And we need to understand both the trend in atomic size and then also the trend or the sort of treatment of ionic size and how forming ions is going to affect the size of our particles. So in general, when we look at the periodic table, so this is a periodic table that I've got sort of annotated for the different orbitals. As we go down a column, so 1s, 2s, 3s, hydrogen, lithium, sodium, potassium, so on and so forth, as we go down, we're going to get to a larger and larger size. And I think that makes intuitive sense because we're going from a 1s orbital to a 2s orbital to a 3s orbital. We're filling in the 4s, 5s as we go down. And those orbitals, the 1s is really small, the 2s is a little bit bigger, the 3s is even bigger, 4s is even bigger than that. So that's intuitive, I think. So as we go down the periodic table, it gets bigger, we expect that. Going from left to right, it's counterintuitive. The numbers are getting bigger, right? If we look at aluminum, silicon, phosphorus, sulfur, chlorine, argon, the number of protons is getting bigger, which is important. Also, the mass is getting bigger, right? Because that nucleus is getting bigger, the number of protons plus neutrons is getting bigger. They're going to weigh more. But the size is going to get smaller and smaller and smaller as I go across this line. So for this 3p line, for instance, aluminum is actually going to be the largest, and argon is going to be the smallest out of this line as I go left to right. So that's a little bit counterintuitive. Not exactly what we'd expect. The explanation for that, right, is that we've got more protons. So these electrons that are filling in this 3p, they're all filling in the same energy level 3p, but argon has 18 electrons in the nucleus, which is basically just going to suck those in a little bit, right? It's just going to have, the electrons out here, it's going to suck them in as we've got more protons in the nucleus attracting those electrons in. So it's a little bit counterintuitive, but just trying to keep in mind that cesium is really the largest. This is the largest size, or I guess francium, if it was stable, but cesium, that's our largest things are going to be down here, and then helium is actually going to be the smallest element. All right, so let's go ahead and see if we can apply that. So krypton, selenium, and selenium 2-. So first we need to find them. So krypton's right here, and then Se, selenium, is right here. So first thing I would do is I wouldn't worry about the ions yet. I would just look at krypton versus selenium and try to place one of those, and then we'll deal with this ionic system in just a second. So krypton's smaller, right? As I go from left to right, that's going to get smaller and smaller and smaller. So krypton is smaller than selenium. So krypton is going to be, on this end, and then I'm going to try to figure out between selenium 2- and selenium neutral, which one's going to be bigger. So this is, now a slightly different topic, right? So it's a different concept where if I have selenium 2-, I've got more electrons for an ionic species that has the same number of protons. The more electrons is going to be, it's larger. So the largest for this one is going to be Se 2-, then Se, then krypton. So that's going to be my ordering for this first one, right? For the second one, aluminum, sulfur, phosphorus. So again, first find them, aluminum, sulfur, phosphorus. So this is just going straight across. We don't have to worry about ions or anything like that. We just need to find where they are on the periodic table. And then this is just the general trend. Aluminum is going to be the largest, and sulfur is going to be the smallest. So this should be ALPS, ALPS. So, as I move along this line, I'm going to get smaller and smaller and smaller because those electrons are going to be sucked in more by the protons. Calcium 2+, calcium and barium. Again, I'm just going to focus first on the species that aren't charged and then go from there. So calcium and barium. Barium is here. Calcium is here. So barium, now we're using that trend going up and down the periodic table. Barium is lower down on the periodic table. They're in the same column, but barium is lower. So barium should be the larger one. So that will be here, barium. Then I need to decide between calcium and calcium 2+. So same number of protons, both calciums, they have 20 protons, but calcium 2+, it's going to have only 18 electrons, whereas calcium is going to have 20 electrons. So the more electrons will be bigger, the less electrons will be smaller when we're talking about ionic systems. So then this one should be calcium and then calcium 2+. So sort of a general trend that you can just try to keep in mind. If we've got the same element, calcium and calcium, the cations, the positively charged species, are going to be smaller, and the anions, the negatively charged species, are going to be bigger. So that should sort of be a hint there. And then, between calcium and barium, we need to figure out which one's bigger or smaller. Same thing here, selenium or krypton, figure out which one is smaller. So hopefully that makes sense. Hopefully that helps. If not, just let me know. Leave a comment below, and cheers.